The time-based filter QoS policy. In an application, a data writer will be sending data as fast as the application code is calling data writer write. For some data readers, they may want all of that data. For other applications, all of that data is too much data. The data may be coming in too fast, and those applications only need a subset of the data to do their job properly. You can use the time-based filter to reduce the amount of data that's received by a data reader. Let's see this in action. If you're using a time-based filter, for example, this data reader on the right-hand side, when you receive data, the time-based filter will set a minimum separation. This minimum separation tells DDS during this minimum separation, do not send any more data to that data reader. So if the data writer is sending data, the application on the left-hand side, the data reader on the left-hand side, will receive that data. The data reader on the right-hand side set a time-based filter with a minimum separation, and that data isn't sent to that data reader. After the minimum separation expires, the next piece of data will be received. But once the next piece of data is received, the minimum separation again is used to filter out any data that's sent during that time. Once the minimum separation expires, the next piece of data is received again. Now, this filtering could happen on the data writer side, the sending application, so that data is not even sent if it's not needed, or it could happen on the data reader side. So if unnecessary data is received, it'll be dropped. Of course, applications that do not set a time-based filter will receive all the data. The time-based filter QoS policy is configured by a parameter known as minimum separation. This is a time that you set in which you don't want data to be delivered faster than this time. So if you set a minimum separation of 1 second, that means you don't want data faster than once per second. So this is commonly known as subsampling, as in you want the data at a lower rate in which it's produced. You only configure this for a data reader. So different data readers can be configured with different minimum separations, even though they're receiving the same data. A real-life example might be that you read the newspaper, so you and I both subscribe to the newspaper, and you want to read it every day. So you may not have a time-based filter. Newspapers published 7 times a week. But I may only want to read the Sunday paper, so I'll configure my time-based filter, my minimum separation, to be 1 week. So I'll only receive the paper once a week. So this really allows DDS to make sure that data readers only get the data that they need. The data writer is sending the data at whatever rate that the application is sending the data. So the data writer logic doesn't even know about time-based filters. However, DDS will know that data readers of a data writer may have different minimum separations, and for those data readers with minimum separations, it'll make sure that it won't deliver data to those data readers faster than those data readers need it. There is no RXO because this is no request versus offered. There's no request. It's not like the data reader requests it because the data writer is not offering. This is not a RXO QoS policy. And the minimum separation is changeable. You can, for a data reader, change the value of the minimum separation during operation. So sometimes you want the data faster, sometimes you want the data slower. Let's take a look at the time-based filter QoS policy for the periodic streaming data use case. So in many systems, there may be data that's published way faster than applications want it, or some applications want it. For example, in an automated vehicle, you may have the vehicle speed being updated 10 times a second, 20 times a second, maybe 100 times a second. In any of those cases, it's much faster than what a human needs it. Human doesn't need to see changes in speed that fast. The graphical user interface may be only updated once per second. So setting a time-based filter to only receive data of vehicle speed, updates of vehicle speed at once per second, makes sense for that use case. Now, why would you want to do that? Well, we can reduce the amount of network that's being used. We can reduce the amount of CPU that's being used. by not sending data that's not needed. Okay, so DDS will try to filter out the data in the sending application when it can, so that unwanted data, unneeded data, filtered out data is not received by the receiving or subscribing application. Of course, we can't do this in all cases. So there are definitely situations in which, even though you set a time-based filter, we can only filter on the reader application. So here are some use cases in which that will happen. You're using a keyed data type, and that's the most common reason for reader-side filtering. So if you have data type that are keyed, or topics that are keyed, by using a time-based filter, we're still going to have to filter it out on the data reader side. Now, if you don't know what a key data type is, I suggest you go ahead and look for a lesson that talks about key data types and topics. Another reason that we'll filter out on the reader side is when you're sending data via multicast. Okay, so often sensor data might be sent to a lot of applications, and the most efficient way of sending the data to a lot of applications is using multicast. So only one copy needs to be sent by the data writer, and then they'll be duplicated using multicast on the network. By doing that, however, this will prevent the writer side filtering for time-based filters, and as well as other type of filters. Now, the other two on the bottom here talks about liveliness, least duration, as well as a publishing mode. These are two other situations in which writer side filtering is disabled. And if you want to learn more about that, I suggest you look at some of the documentation about liveliness as well as the publishing mode QoS policies.